today we're going to be going through your logistics. So we've got question 1, which is 4 times, and then we've got in the brackets 6 minus 3. Using BIDMAS, we know we do our brackets first, so it becomes 4 times 6 minus 3, which is 3, 4 times 3, which is 12. For the next one, a multiplier, that's how we write our percentages as a decimal. But the important bit here, with decreasing, so we're going to have to take it away from 100 first. So we do 100 minus 35, which gives us 65. To write it as a decimal, we divide it by 100 because that's what a percentage is out of. So 65 divided by 100 gives us 0.65. That is our multiplier. That is our answer. We're done. For number 3, 4/5 of 100. First thing we do is we divide by the denominator. So we divide by 5, which gives us 20. And then we multiply by the numerator. So it becomes 20 times 4, which is 80. So 4/5 of 100 is 80. Converting to a percentage for this one, we need to know what a percentage is out of, which is 100. So our denominator, we want to be 100. So we do 13 over 20. To get 20 up to 100, we need to times by 5. So we times the numerator as well, which gives us 65 over 100. 65 out of 100 is the same as just saying 65%. So our answer is 65%. For number 5, we're looking for the 2 solutions for this equation here. We've got x plus 3 and x minus 5. We want to make each bracket 0 individually. So we're looking for a number that when we add 3, we get down to 0, which would mean x equals minus 3. The easy way to spot it is we do the opposite to the bracket. So if we're doing the opposite to x minus 5, we'd say x equals plus 5 or just 5. For 6, the nth term, we find the difference between each of these. In this case, we are adding 7 every time. That means we put the 7 in front of the n, so it becomes 7n, and we ask ourselves, what's the difference between 7 and 3? If we're on 7, how do we get down to 3? We minus 4, so it becomes 7n minus 4. For the next one, we're looking at a probability tree, and we're told a little bit of information. First thing we're told is the probability that Megan passes a test is 0.8, and the probability that Rosie fails is 0.3. Your probability tree is actually on the back. So what you're going to do, you're going to write them on the back. So here's our probability tree. We've got Megan, and we know Megan passes is 0.8. So the pass, we're going to write 0.8. And Rosie failing the test is 0.3. So under Rosie, on both of the fails, we're going to write 0.3. We're missing a little bit of information, but we know each branch on our tree, so each of these, needs to add up to 1. So this must be 0.2. This one needs to add up to 1, so that must be 0.7. And the same goes for this one. It's got to add up to 1, so it's 0.7 again. That's question 7 done. And then question 8 asks us to use our probability tree to work out the probability that both girls will pass the test. So looking at this, Megan passing is 0.8, Rosie passing is 0.7. As we move through our tree, we multiply our probabilities. So we're looking for the pass followed by a pass. So we do 0.8 times 0.7, which would give me 0.56. So the probability that both of them pass would be 0.56. Okay, expanding brackets. We use FOIL. So we've got FOIL down the side. F is for the first, so it's x times x, which is x squared. O is for outer, which is x and minus 6, so it becomes minus 6x. The inner is minus 5 times x, which is minus 5x. And the last is the last in each, so the minus 5 times minus 6, which will be plus 30, because a minus times a minus gives us a positive. These two we can add together because they've got the like terms, they've both got just the x. These two we can't do anything with, so we end up with x squared minus 6x minus 5x, which is minus 11x, plus the 30. And the very last one, state Pythagoras theorem, which is just a squared plus b squared equals c squared.